Hi, in this session, I would like to share a step-by-step how to draw shear force and bending moment diagram. From the diagram, we can determine maximum shear force and bending moment value. Before we start to draw the diagram, we have to know three important things. One, you have to know how to draw free body diagram. Second, you have to understand the equation of equilibrium of summation of F and summation of M. The third one, you have to know how to do the imaginary cut section by section. Now, let's do our free body diagram. This is our beam. You have to understand there are two types of load at the beam. The first one is applied load, or also known as an external load. The other type is reaction load. It is very easy to identify the applied load because usually the applied load are already given in the question. In this question, our reaction load consists of two concentrated moment at the point A and D and two concentrated force at the point B and C. For the reaction load, it is usually act at the support of the beam. So here we have two support. The first one is a roller support. Oh, sorry, this one is a roller support and this one is a pin support. Pin support at point A and the roller support at the point D. Okay. The corresponding forces for the support pin here are look like here. We have one vertical force and another one is a horizontal force. The value for horizontal force is 0 because it is the only horizontal force act on the beam. Remember, all the vertical and horizontal direction should be cancel each other out to remain its equilibrium. Alright? Okay. The corresponding force for a roller support here is look like this one. Just one vertical force. Okay, now this is our free body diagram. But our free body diagram is not complete yet because we still don't know the value of VA and we still don't know the value of VD. And this one is the three main steps we have to follow. The first one is FBD, second is summation of F, the third one summation of M. You can determine all the unknown variables by follow these main steps. Okay, we already draw the FBD. We go to the second step. The second step here is summation of F equal to 0. Here I declare upward direction is positive. Okay, it's up to you whatever direction you want to declare as positive or negative. There are a few reference in the website declare downward direction is positive. Don't worry, whatever you declare, it is equilibrium condition. It is in equilibrium condition. At the end of the equation, you will get the same answer. So now we have four forces. 1, 2, 3, 4. Alright? So that means we have four values to sum out. The VA is a positive that is a upward direction. So that means it's follow what we have declared is a positive. So here 30 is a downward direction. That means it's against what we have declared. So it becomes negative. So the same condition here, upward, downward direction. So you get negative. Okay, the last one is the VD. The VD here, we don't know, just put a VD here equal to 0. At the end of the solution equation here, you can get VA plus VD equal to 80. And this equation, the last equation, simplified equation, I named it as equation number 1. Next, we go to the step 3. Summation of moment equal to 0. Alright, this is the equation. Okay. I declare the clockwise direction moment is positive. Okay, it's up to you whether you want to counterclockwise positive or clockwise positive. My scholar, I use clockwise direction moment is positive. So this one is a summation of m at the point D here. All right. You can define it at the point A. If you define it at the point A, you can get the VD value at the last equation here. Okay, the last solution here, you can get the value of VD. If you define moment at D, you can get the value of VA. All right. You can't define either point B or C because at the end of the solution, you will get two unknown variables and it's difficult to solve equation number 1 later. Alright, here we have two concentrated moments and we have four forces. All the forces will develop a moment. Alright, so that means we have a 6 values of moment to sum out. The first moment is 12 Newton a meter. Here, I put it as a positive. The second one is a VA is a force. D is the distance. The distance from from this point D to point A, 3.6. FD is the formula for the moment. VA multiplied with 3.6. This at the point B here, 30 kilonewton. 30 multiplied with D, 2.4. 2.4 is the distance from B and D. So here, I give a negative sign for this moment. Why? Okay, it's okay. I know many of you still don't know and understand how to identify the positive or negative sign of moment. So let me show you how to get positive or negative sign for the moment. Okay. Okay, let me draw. Okay, let's say there is a 4 point A, B, C, and D. Okay, at the point D here, we got the upward direction of force. Here we got a downward of direction of force, and A we got a downward direction of force. So I declare here the M at B is positive if clockwise. Alright, let's say this one is our beam. Okay, I hold the beam at the point B because I define at the beam, moment at the beam here, and there is a one force, downward force, upward force here. Alright, upward force. If there is an upward force, so what's happened to the beam? Okay, the beam will try to rotate, to bend counterclockwise. Okay, the beam try to counterclockwise, to bend counterclockwise. So this means it's against what we have declared here. So this means we get negative. So what happened to C here? We got a downward direction of force. Okay, it's okay. Just pull here. So we push here. So that means there is a downward here. The beam will rotate clockwise. The beam will rotate clockwise. So the beam will rotate clockwise. It's follow what we have declared. So it become positive. So what happened here? The B here. Okay, the other side here. If there is a downward force here. So what happened to the beam? The beam will bend counterclockwise. So it's against what we have declared. So that means it's become negative. I hope you can understand how to identify the sign of the moment. Alright, back to our PowerPoint back. Sorry, we have to go back to our camera again. Okay, to the beam again because I forgot to share what happened if there is a force at the point B. Okay, if there is an upward force here. All right, what happened to the beam if there is a force, one concentrated force at the point B here? what happened? There's nothing happened to the beam because why? The moment is zero. The moment is zero. Okay. Why? Because the m equal to fd. We have a value of f, but the value of d is a zero. Okay, so the moment is zero. So nothing happened to the b, and the moment is zero. Okay, again, we back to our presentation slide. Okay, so that's why we get a negative sign here. All right. Okay, next, the 50 kilonewton here. Okay, sorry. Okay, we have a 50 multiplied with distance 1.2 from point C to point D 1.2. Get a negative here. The same condition with a 30 here because we have a downward direction of force. So here directly we can take as a 24. The direction is against what we have declared earlier. So at the point VD here, we still have a force, but the value of moment is zero because the distance is zero. So then you solve this equation, you can get a VA equal to 40. All right, this VD, the distance is zero. You can get a 40 here. All right, the VA, okay, get a VA and get equation 1, you can get a VD equal to 40 kilonewton. Now, our FBD is complete. Okay, next, just like what I have told you before, you have to know how to do the imaginary cut. All right, section by section. You have to cut the beam. Actually, this is not the cut the beam. We just do the imaginary cut. So we have a three section here. Three section 1, 2, 3. So we have to do the three. We have to do three imaginary cut. All right. Okay. Actually, we want to determine the internal shear force and bending moment along the beam. Once you do the imaginary cut, okay, for this section, from 0 to 1.2, so I just this distance is just put an x. So once you cut at this point here, you will get a internal shear force and internal moment. All right. The first part is at a range of 0 to 1.2. At the cut point, we have two load. 1, 2. Okay, before that, you have to remember these three main steps that we have to follow. All right. This one is a very powerful tools. Okay, we have done our FBD, so we go to summation of F for the second step here. All right. This is the equation. So we have two concentrated forces here. So that means 1, 2. We have the two values of force that we have to sum out equal to 0. Okay. So this one is a 40. Is a upward direction positive, and this one is a downward direction is a negative. V cut equal to 0, V cut equal to 40. So we go to the third step is a summation of moment. All right, we go to the 12. So directly we can go get it 12, and this one is we declare as a clockwise direction. Oh, the M is declared defined at the cut point 12. All right, 40 multiply with d, the distance. Distance is x from point A to cut point here. So FD 40x plus, okay, 40 v cut here. We get a value from this step, 40 multiplied with 0. Alright, so the moment will become 0 here. So this one is a M cut. Is the direction against what we have declared, so it becomes negative. So at the end of the solution equation here, you can get m cut equal to 40x plus 12. And let's say the x value is 0. The x value is 0. The m value will become 12. All right. If the x value is 1.2, at the 1.2 here, the moment will become 60. All right. We go to the next section here. The next section here is from 1.2 to 2.4 at this range. So we just cut anywhere, any point within this range. So that's why our x distance is x. We don't know the distance yet. All right. The full length is x. So at this point here, 1.2 as given in this FBD. So at the point B to this cut is x minus 1.2. All right. The distance between B and B cut. Okay. Once you do the cut, we will have internal shear force here and internal moment here. All right. Okay, after done your FBD, don't forget your these three main step. Done FBD, go to the second step, summation of M. So how many force do we have? 1, 2, 3. So three forces, three value of forces here. We have a 40 plus a negative downward direction negative, and downward for the V cut is negative, then you can get a V cut equal to 10 kN. Okay, the next step is a summation of M. Okay, summation of moment. We have how many moment here? 1 2 3 1 2 3 1 2 3 4 5. We have a 5 values here. 1 2 3 4 5 values. We go one by one. This one is a 12 kilonewton meter, and this one is a 40 kilonewton here. Multiplied with d is a distance between the distance from cut point to A, the x value. Okay, this one is a 30 multiply with the distance is x minus 1.2. all right, and then our 10 we cut here we get it from here, the value is coming from here, multiplied with a 0. all right, the distance is a 0, and the last one is our moment here is a negative m, because it's a direction against the direction against what we have declared. Then at the end here you get a linear equation, m cut equal to 10x plus 48. Okay, let's say the x value is 1.2 here, we get a moment 60 at this 1.2 at the B point here. All right, if your x is equal to 2.4, you can get m equal to 72 kilonewton a meter. All right, so next we go to the other section. The third section is from 2.4 to 3.6. Okay, from 2.4 to 3.6. So we just do some empty cut here. We don't store the value from A to cut. We just name it as an X. Alright, as X. Then we just follow the three main step. Summation of F here equal to 0. Alright. So how many forces do we have? 1, 2, 3, 4. 1, 2, 3, 4. We go one by one. 40 upward positive, and this one is a downward, the sign is negative. So this one is a 50, the sign is negative because it's a downward direction, and this one is a V cut, downward direction, negative V cut, and at the end you will get a negative of 40 kilonewton. We go to the last step, summation of M equal to 0 here. Okay, summation of m. So how many moment do we have? We have a two moment and four forces which will develop a moment. So that's been total up. We have six moments here. One, two, three, four, five, six values of moment. So we go one by one. Our 12 here, 12 is positive because it's follow what we have declared the direction. Okay, clockwise. Okay, it can be positive plus 40x. The 40 is the value of force and d the distance from point A to to the cut point. So the distance is x. So we have here 30. 30 multiply 30 for the value for the force, d for the distance. So the distance is the distance from point B to cut point x minus 1.2 here, then you can get the distance x minus 1.2. This one is a 50. 50 is the f value, the force value. D is a distance from C point to the cut point. Okay, the x minus 2.4, so we can get this distance x minus 2.4. This one we cut, we got a value of negative 40 here from the step 2. All right, but the distance is 0. The distance is 0, so the moment is 0. Okay, the last moment here we got a negative m. Why? Because why negative m? Because what I have explained it before, because it's against what we have declared, the direction. The direction is against what we have declared. Okay, so it become negative. So at the end of the solution here, the equation, we got a linear equation again. M cut equal to negative 40x plus 168. Let's say the x value is 2.4. We can get a m value is 72 kilonewton meter at this point. If the value of x is 3.6, we get a value to 24 kilonewton meter. Okay, done. Okay, last slide. The last slide is we have to draw the shear diagram, shear force diagram, and the bending moment diagram. Okay, we go one by one. Okay, this one, the first section is from 0 to 1.2. We have one equation here, v cut equal to 40. Okay, v cut equal to 40. That's been our shear force diagram here. We can draw a straight horizontal line at a 40 kilonewton. All right, okay, we go to the moment here. At the moment equal to 40x plus 12. So this one is a linear equation. Okay, remember the linear equation, the general equation, y equal to mx plus c. So the c is the value of at a y-axis 12. All right, so this 40x is a plus. That means the slope is upward. Okay, upward. So if the x value is 0, we got a 12 value at the point m here. Okay, at the point 0 here. So if the x is 1.2, you can get a 60. All right, then we go to the next section, the next cut. Okay, the next imaginary cut is from 1.2 to 2.4. All right, the v cut is 10 kilonewton. So we draw a straight line, horizontal line at a 10 kilonewton here. Okay, so what happened to our bending moment diagram? Okay, we have a linear equation. We can get here at the point 1.2 is a 60 kilonewton meter. If the x value at the x value of 2.4, you can get a 72 kilonewton meter at this point. All right, okay, then the third imaginary cut from 2.4 to 3.6. All right, from 2.4 to 3.6 here, we have a V cut equal to -40. We just draw the -40 here, 40, and you close up your graph. Okay, then this one m value. The m value here we can say it's a negative. This one the sign is negative. That means the slope is uh, downward. Yeah, go to the downward. Go downward. So if the x is 2.4, is become the m value is 72 kilonewton meter here. All right. If the x value is 3.6, you can get 34, and you close up your graph. Okay, then we have complete our mission to draw shear force diagram and the bending moment diagram. So from the diagrams, we can see and get the maximum shear force is 40 kilonewton, and the maximum bending moment at this point 72 kilonewton meter. All right. Okay, before I end up this session, I just want to share something, the importance of shear force and the bending moment diagram. Let's say the maximum allowable shear force for this beam is 100 kilonewton. But we want to allocate 100 kilonewton shear force at this point, 1.5. Can we allocate 100 kilonewton shear force at this point, 1.5 here? The answer is no. Because why? Refer to the shear force here. At this point, 1.5, we already have a 10 kilonewton shear force. So that means we only left 90 kilonewton force at this point. Okay, that's the importance of the shear force at the bending moment diagram. Okay, I hope this session is very useful for you. If do you have any question, please write an email to me, azwan.nasir@gmail.com. Okay, that's all. Thank you.